In this video, we are going to study about Baudhayana's method for circling a square. Now, what is meant by circling a square? We will be given a square, and from that square, we have to construct a circle such that both the square and the circle have the same area. So, let us see this by a small example. So, we are going to take a square of side 5 units and going to draw a circle which is having the same area. So for that, I will take perpendicular bisectors of both the sides, and the intersection of these perpendicular bisectors is E, which I am showing in the figure. Now this perpendicular, we are going to draw a circle from the center E with radius D, with radius ED, and that you can see the circle is passing through all the four corners of the square. This perpendicular bisector intersects the circle at point F, you can see that, and it intersects at G with the square. So we are going to take 1/3 of this FG. This FG we are going to divide into three parts, and the 1/3 of that part length I'm going to call HG. So the length HG is actually 1/3 of the length FG. And now we are going to draw a circle through this point with the center as E. Now the original square has side 5 units, so the area of that square is going to be 25. And if you calculate the area of this circle, the new circle that we have got, which is having radius HE, that circle is having area approximately equal to 25.4. So this is the way Baudhayana's method of circling a square tells us that the circle that you can see inside and the square, the original square, both have areas which are very close to each other. From the video, you have understood that the square and the circle have approximately the same area. Now let us try to mathematically convince ourselves that both of them are indeed close to each other. So you can see in my figure that I have taken here, I have taken a square and I'm assuming that this square has length 2a. So this entire thing is 2a. So if I make the half of that, that half is nothing but a, which is eg. So this ag is also going to be a because it is 2, the length total is 2a. So this is a. So here I see a right angle triangle now. And by Pythagoras, I'm going to get it as a root 2. Okay. So let us try to see now how am I going to use this a root 2 and construct a circle. So when I'm given a square of length 2a, I will first find the center of the square as we did in the video before. Then this gives you a. This point AP is the length AP is also a. So by Pythagoras, I'm going to get a root 2. Now using this a root 2, what I'm going to do is initially construct a circle which you can see in the dark line, a black circle, complete black circle. So that circle has radius, how much? That circle has radius a root 2. Now, as we discussed in the short example before, what we did is we extended this EG and joined till F. So this is the entire length EF, and the length GF, this was the length GF. This length GF was divided into three parts, equal three parts. So I will say that GF is divided into three parts, and those points, one of the point I'm calling P. So if I calculate GP, GP is actually what? GP is actually 1/3 of GF. Correct? So how much is the length GF? You can see here in the figure that GF will be how much? A root 2 minus A. GF will be A root 2 minus A. Because this total length is, this total length that we have here, this total length is A root 2. And this, so this total length is also A root 2 because it is the radius of the circle. The complete EF is the radius of the circle, out of which this part is this part is A, out of which this part is A. So what will be the removed length? The length will be, that removed length will be obviously, which we are calling GF. Let me scroll it down so that we can see a new figure. So this removed GF, now you can see in the figure, this GF, that is how much? That is A root 2 minus A, right? But what was GP? As we have seen GP was 1/3 of GF. So GP is how much? 1/3 of A root 2 minus A. I have written it here. You can see. So GP is actually 1/3 of GF. That's why it is 1/3 of A root 2 minus A. And therefore, this entire radius, radius of the smaller circle, the radius of the dotted circle that you have, it is this. This is the radius of the circle, which is EP, right? So EP is the radius of inner circle or a smaller circle. And this circle was the circle we have to find the area. And this circle will have the area same as the area of the square, right? So how much is EP? Obviously, EP is going to be what? EP is going to be, by the figure you see, it is EG plus GP. But EG is how much? EG was A. And GP we have found out here. It is 1/3 of A root 2 minus A. Now we will simplify this. So this will become A plus A root 2 by 3 minus A by 3. And if I make the denominator common, 3 to all of them, so I'll have 3A plus A root 2 minus A, which is 2A plus A root 2 divided by 3. So let me write it as A 2 plus root 2 divided by 3. So this is EP, which is the radius of the circle, okay, and which I'm going to call R. R is equal to 2 plus root 2 divided by 3 multiplied by A, okay. And now let us find the area of the circle. So in that case, what is the area of a circle given by? So area of circle according to us, it is like pi r square, which is pi into 2 plus root 2 divided by 3 square into a square, right? Because we have taken r is equal to how much? R is 2 plus root 2 divided by 3. And we are now going to use a very important approximation of pi. So that important approximation of pi is 9 into 6 minus 4 root 2. Okay. Now let us see how to remember this approximation. Okay, let me just simplify this. So this is pi into, when I simplify this, this whole square will be 9. This will be 4 plus 4 root 2 plus root 2 square will be 2, and the a square is as it is. So you see that this simplification will become 6 plus, so it is pi into 6 plus 4 root 2 divided by 9 times a square. And this is how if I want to simplify this complete expression, okay, I'm going to have a value of pi which includes a 9. So that 9 should cancel. So I'm going to evaluate the value of pi now that we have written above. So it is 9 so that this 9 will cancel this 9 afterwards, and multiplied by what? Multiplied by the conjugate of this complex number, the I'm sorry, conjugate of this number, which I'm not complex number, 6 minus 4 root 2, and I'm going to multiply it by 6 plus 4 root 2, which is already there, and then I'm going to multiply it by a square. So eventually this 9 and 9 will cancel. Okay, and so what is 6 plus 4 root 2? 6 minus 4 root 2. So I'm going to use 6 square minus 4 root 2 whole square times a square, right? And which is 36 minus 32. So it is 4 into a square. So this is just 4a square. And this is nothing but what? This is nothing but 2a the whole square, which is nothing but what? Which is nothing but the area of square. Why it is area of square? Because I know that the square that I've started with has side equal to what? Has side equal to 2a, right? So there's only one thing that we have to take care of here. We are writing equal to everywhere. Actually, I should have written what? In the in this step, I should have written it as approximately equal to, because I'm substituting the approximate value of pi over here. Okay, so we have now proved that area of the circle, which is pi r square, is approximately equal to the area of the square.